The dawn of light, unveiling the universe's first monsters. In the crushing blackness of the early universe, just 600 million years after the Big Bang, a monster was awake. It was devouring matter at a ferocious rate, screaming across the cosmos with the brilliance of a trillion suns. This is the story of the oldest quasar ever discovered, a beacon from the dawn of time that is rewriting everything we thought we knew about the first galaxies. To understand why this discovery shakes astronomy to its core, we have to go back to the beginning. The Big Bang created a universe that was almost perfectly smooth, a hot, dense soup of particles and energy. For hundreds of millions of years, there was no light, no stars, no structures. This period is known as the cosmic dark ages. Then, gravity began to work. Tiny fluctuations in density grew. Gas clouds collapsed. The first stars flickered on, burning with a pure, violent blue light. But stars alone could not illuminate the cosmos fast enough to match what we see in the deep field images from the James Webb Space Telescope. Something else was needed. Something massive. Something hungry. Enter the supermassive black hole. These are not the stellar mass black holes formed when large stars die. These are titans, millions to billions of times the mass of our Sun, sitting at the heart of nearly every large galaxy. Our own Milky Way hosts Sagittarius A*, a relatively quiet black hole with the mass of 4 million suns. But in the early universe, these monsters were anything but quiet. When a supermassive black hole feeds, it does not simply vanish into the darkness. As matter spirals inward, it forms a blazing accretion disk, heated to millions of degrees by friction and magnetic forces. The energy released is beyond comprehension. Before crossing the event horizon, some of this matter is blasted outward in powerful jets traveling at nearly the speed of light. The result is a quasar, the most luminous persistent object in the universe. For decades, astronomers believed that quasars took time to grow. The Standard Model suggested that black holes built up their mass through mergers and accretion over billions of years. But the oldest quasar, designated J0313-1806, shattered that assumption. It existed when the universe was only 5% of its current age, yet its central black hole already weighed in at 1.6 billion solar masses. How did it grow so fast? This is the million-dollar question that keeps astrophysicists awake at night. One theory is that the first black holes formed from the direct collapse of enormous gas clouds, bypassing the star formation stage entirely. Another possibility is that they grew through episodes of super-Eddington accretion, consuming matter at rates that should theoretically be impossible. The light from J0313-1806 has been traveling for over 13 billion years to reach our telescopes. When it began its journey, the Earth did not exist. The Sun was not even a glimmer in the interstellar medium. Our entire solar system, with its rocky planets and gentle yellow star, would not form for another 8 billion years. What makes this quasar even more extraordinary is its environment. Observations reveal that it sits within a host galaxy that is furiously forming stars, up to 200 solar masses per year. For comparison, our entire Milky Way produces only about 1 or 2 new stars per year. The quasar and its host are growing together in a cosmic dance of creation and destruction. The radiation from the quasar is so intense that it ionizes gas out to a distance of 100,000 light-years, creating a massive bubble of charged particles. This process, known as reionization, is one of the most important phase transitions in cosmic history. The quasar is not just a light source. It is an engine that is transforming the intergalactic medium, tearing electrons from hydrogen atoms and ending the cosmic dark ages. But observing quasars from the dawn of time is not easy. They are incredibly far away, and the expansion of the universe stretches their light, shifting it from visible wavelengths into the infrared. This is why the James Webb Space Telescope, with its unprecedented infrared sensitivity, has become the ultimate tool for probing the first billion years of cosmic history. Webb has revealed that early quasars are not rare anomalies. They are part of a complex ecosystem of galaxies, black holes, and dark matter that evolved with shocking speed. In fact, some of the earliest quasars show signs of being surrounded by companions, smaller galaxies being cannibalized by the quasar's host. This hierarchical growth through mergers is likely a key piece of the puzzle. The implications stretch far beyond astronomy. The existence of such massive black holes so early in the universe tells us that the first structures formed with an efficiency that challenges our models of cosmology. It suggests that dark matter, the invisible scaffolding of the cosmos, clumped earlier and more densely than we predicted. There is also a profound philosophical dimension to this discovery. When we look at J0313-1806, we are not just seeing a distant object. We are looking back to a time when the universe was still in its infancy, when the first sources of light were just beginning to paint the canvas of the cosmos. That light has carried the story of our origins across 13 billion years, arriving at our telescopes as a faint whisper from the dawn of time. As we push the boundaries of observation with next-generation facilities like the extremely large telescope and the space-based LISA gravitational wave detector, we will likely find even older quasars. Each discovery refines our understanding of how structure forms, how black holes grow, and how the universe transitioned from a featureless expanse to the rich, structured cosmos we inhabit today. The oldest quasar is more than a record breaker. It is a time machine. It is a window into the physics of extremes, where general relativity and quantum mechanics collide in the vicinity of the event horizon. It is a reminder that the universe, in its earliest moments, was capable of producing wonders that defy our intuition and expand our imagination. We are living in a golden age of cosmology. The data streaming in from space telescopes and ground-based observatories is transforming our view of the early universe on a monthly basis. Quasars like J0313-1806 are the lighthouses of this new era, guiding us toward a deeper understanding of the cosmic dawn. As you look up at the night sky, remember that the darkness is filled with ghosts. The light from the first monsters, the quasars that illuminated the young universe, is still arriving at Earth. It has crossed the vastness of space and time to deliver a message from the edge of the visible universe. A message that says the cosmos was born not in silence, but in a blaze of glory, with monsters awake in the dark, shining with the light of a trillion suns. The quest to understand these ancient beacons is far from over. With every new telescope, every new observation, we peel back another layer of the cosmic onion. We are the first generation in human history to see the universe as it truly is, in all its violent, beautiful, and terrifying complexity. And the oldest quasar is just the beginning. Thank you for watching. If you enjoyed this journey to the dawn of time, please like, subscribe, and hit the notification bell to join us on our next exploration of the cosmic frontier. The universe is waiting.